So today we're going to look at a video comparing the safety squat bar to the traditional back squat. Both videos have the same lifter performing a maximal attempt. You'll notice as the lifter descends, the descent is similar between both squats, but you will notice some slight changes on the way up. When viewing the safety squat bar, you'll notice the weight is a little more in front of the lifter. This results at the bottom position being slightly more vertical when compared to the back squat. You'll notice with a traditional back squat, the lifter moves posteriorly. Under the conditions of the safety squat bar, a posterior shift results in a rounding of the thoracic area, showing a weakness of the thoracic extensors. The next series of videos will show muscle activation from 7 muscles which were measured during both trials of squatting. This first video shows the safety squat bar and depicts EMG through a bar graph. You'll notice activation increase during the eccentric portion, but significantly more activation during the concentric portion of the lift. Here we will see the same video with a different depiction of the EMG activity. You'll notice the whole EMG activity is recorded now in a graph format. Notice now the decline in muscle activity as the lifter is in the bottom of the hole, and the increase as he reaches the sticking point. We will now view similar EMG activity during the traditional back squat. You can view the quads being significantly more active than the hamstrings or glutes as the lifter comes out of the hole. This brings up the idea of the lumbar's paradox when squatting. The quads will be more active than the hamstrings, even though the hamstrings are involved in hip extension. Due to knee extension being required to get out of the hole, the hamstrings cannot contract more than the quads because then the quads would not have the reciprocal inhibition needed to stand. I hope you found this video educational and something that you can apply in your everyday squatting.